Hello, tikulandireni pamene tikupitiriza phunziro lathu la variations. Tili mu lesson 3, ndipo mu lesson 3 tiona inverse variation. Ndipo muli ndi ine Cecil Juma, tikhalire limodzi. Tikakamba za inverse variation, kwambiri timayang'ana variables. For example, two variables actually, x and y. If the product of the two variables is constant. The product of the two variables is constant, meaning to say that x, y to be equal to constant. Mukazita imusa izi kazi kuchuluka kazi kutani, the outcome should always be constant. In other words, tikakamba za variation tinakambapo kuti representation of variation ndi akulu awo. And last time tinaonikirana the direct variation to say if x, y, it means x is directly variated to y, and tinanena kuti x can as well be written as k, y, something like that. You introduce a constant if you put an equal sign. The same applies to this one. It means for them to come to this point, it is that x inversely variated is 1 over, like that, 1 over y. Then if you introduce an equal sign there, it will be k. You introduce a constant over y, and if you make k subject of the formula, it will be k is equal to xy. So that's where the definition is coming from. If you multiply these two, the constant, the outcome should always be the same. Okay, k should be if you multiply x and y, if you multiply those variables, the outcome should always be constant. I hope that is making sense, and I think it will make more sense when we look at examples. Now, for the meantime, let's look at real-time examples. Two numbers are having two variables. In that case, to out x and y, the outcome to remain constant, something like that. So, in real-life examples, you might consider, let's say, fresh vegetables. Okay, mutogula masamba. Fresh vegetables and time. Okay, mukagula masamba lero mukasunga amauma amanyala. Okay, so the freshness of vegetables is inversely proportional to time. Okay, as time goes, masamba jasama kalaswa fresh, the freshness goes away. Okay, yeah, something like that. Tiangane issue in expenses. Okay, we are looking at the variable say expenses and savings. Okay, eno mutokumasunga ndalama koma ngati mukumagula zinthu ndalama zizichepa. Okay, so the more the expenses, the less the savings. So that's the relationship. Okay, you can think of when I saw a room and chairs. Okay, the more the chairs, the less the room you are going to have, the space in a room. Okay, zinthu ngati zachuluka mulumu space isikhala yochepa muzi swabo ponda. Zinthu ngati zachepa mulumu space ikhala yambiri poponda pazipezeka. So that's the inverse relationship imene tikunena. Okay, so in this inverse proportion, or in this inverse variation, it's basically the concept that If one quantity increases, then the other quantity decreases at the same rate, and of course vice versa. Okay, ngati zinthu zikuchuluka in this relationship, zinazo zimayenera zichepe, komano zimene zizichitika mofanana. Yeah, so let's continue. And on those examples, we can as well consider speed and time. Mukakwera galimoto, ngati driver akuthamanga kwambiri, zikutengerani kanthawi kochepa kuti mukafike kumalo kumene mukupita. The higher the speed, the less the time taken to reach your destination. Kwanza tamene timapanga physical science, you may consider of resistance and current. We know that voltage is equal to okay. Yeah, so you see that current will be equal to V over R. So this voltage is supposed to be a constant. Okay, so current and V are inversely related. The higher the current, the less the resistance. The higher the resistance, the less the current. Just like that. So at this juncture, let's look at examples to help us understand more of this concept. The first example, akunena kuti the time taken, that's time t taken by a car to cover a given distance, varies inversely as speed. So varies inversely as speed. So it's varies inversely as speed, just like that. Now they're saying at 60 km per hour, the car takes 3 hours. So at 60 km per hour, this is the speed. Car takes 3 hours. Okay, so at this speed, 60 km per hour, gari moto kumatenga 3 hours kuti ikafike. So they're saying model expression that expresses t in terms of t. So tipange ngati formula, tipange chizindikiro choonetsa zimene zikukambidwa apa. So this is the inverse relationship that we have put here. Now we are saying we need to bring in a constant. If we bring in a constant, we put equals just like that. So this constant has to be known. So it will be S and T. Okay. Remember the first one, we are given speed as 60 km per hour, time as that one. So it will be 60 times 3. That will give us 180. That's our constant. So our expression in this case is T will be equal to K, which is 180 divided by S. So in this case, we have expressed time t in terms of S, okay, by knowing the constant. So we are doing this because we might have, let's say, we might be asked to find the time that will take us to reach our destination. If the driver decides to increase the speed to 70 kilometers, that should be kilometers per hour. So we are going to use this expression that we have developed, or this model that we have developed. Let's first. Here is another example where we are saying y varies inversely to x, that is to say y varies inversely to x, and here we are given, what are we given? We are given y is equal to 60 and x is equal to 12. Now we have been asked to find find x when y is equal to 25. So that's the relationship that we have been given. That's the expression that we have been given. So for us to make it in a way that we should introduce an equal sign. And for us to introduce the equal sign, we will need to bring the constant. Okay, just like that. Then we know that k in this case will be equal to x, y. Okay, so that's the inverse relationship. From there, we are given y is equal to 60 and x is equal to 12. That is for us to find the constant. We need to know our constant for us to express y in terms of x, so that we should be able to use these values for us to find x. And x and y we are given. We are saying 60. That's y times 12. So if we say 60 times 12, that will give us 60 times 12. That will give us 720. And 720, yeah. So we are going to substitute this back into our equation, where we are saying y is equal to, where there is k, we are going to put 720 over x, something like that. So this is our model, or this is our expression, which can help us to find the value of x or to find the value of y. Okay, so that will mean any value of y, but remember that constant will always remain the same for an inverse variation. K will always remain the same. The constant is always the same. So you can change these values, but that one has to be the same to follow this relationship. Then in this case, they are saying find the value of x when y is equal to 25. So to find x, for us to find x, we have to make x subject of the formula. Okay, so making x subject of the formula, we have done subject of the formula. I'll not dwell much on it. I'll just put it here. It will give you x will be equal to 720 over y. We have a lesson on making subject of the formula, so go revise. And in this case, we are given to find x, in this case when y is equal to 25. Therefore, when y is equal to 25, x will be equal to 720 divided by, where there is y, we are going to put 25. Okay, it should be equal to, so 720 divided by 25 give us 28.8. So which means when y is equal to 25, x will be equal to 28.8. Another example, in this one they're saying the number of days represented by d, number of days it takes to the number of days it takes to paint a wall is inversely proportional to the number of men available. Number of men represented by n to do the work. Okay, inverse relationship. So number of days, that is d, inversely related to number of men. Okay, number of days represented by d, number of days, and the number of men represented by n to do the work. Okay, chimene akutanthauza machonena kuti ngati anthu alipo ochuluka ntchito imagwiridwa mofulumira. Okay, in other words, the more the people, the less the time it take to complete a given task. Anthu akachuluka nthawi imatengedwa yochepa kuti amalize ntchitoyo. So that's the inverse relationship. And now they're saying 12 men take 15 days to paint the wall. Okay, and we are given that 12 n, I mean men, 12 men. Remember, men is represented by n, is equal to 12. And we are being told that it takes 15 days to paint the wall. So how long will it take to paint the wall? Okay, that's that. So let us now first of all find the constant for us to have a complete expression. So we need to do that. For us to remove that proportionality, we need to bring in k equal sign and k, which is constant, over n. And in this case, k will be equal to n times d. And n times d will be 12 times 15. 12 times 15 will give us 180. Okay, will give us 180, which means our expression will now be 180 over n. So this 180 will remain constant at every instant. Okay, and now they are saying how long will 18 men take to paint the wall. Azibambo 12 anatenga masiku 15 kuti akwanitse kupenta khoma. Panopo aonjezera pazibambo 12 aja 6 kukwana zibambo 18 apenta masiku angati. Okay, so now they are saying when n is equal to 18, okay, and now we need to find number of days, which is d. Okay, so it's a matter of just substituting. So d will be equal to 180 divided by 18, which will be equal to 10. Okay, which will be equal to 10. 180 divided by 18, if you do it on your calculator, it will give you 10. Therefore we can say, therefore 18 men took 10 days to complete the work. Okay, now let us present inverse variation graphically. We are going to consider the example just saw, which we had when d is equal to 108 over n. From the look of things, number of days depends on number of men. Okay, the number of men, which means number of men is independent. So let us put up a table variable, n, that's number of men. Let's say we can start from 2, 4, 6, 8, 10, 12, 14, maybe 16 men. Okay, so number of men. Now let's see number of days. Now if men are 2, our number of days will be 90 days to complete the work. If men are 4, it will take us 45 days to complete the work. And if men are 6, it will take us 30 days. If men are 8, it will take us 22.5 days. If men are 10, it will take us 18 days. If men are 12, it will take us 15 days. if min 14, it will take us approximately, let's just say 13 days approximately. If min are 16, it will take us 11.25 days. If min are 18, let's say if min are 18, it will take us 10 days. Okay, so you first of all have to come up with the table of values. After coming up with the table of values, we need to now have a plot. Now let us put this information on a graph. Okay. Yeah, so this is D and this is N. So in this case, that's 2. So okay, say 1, 2, 3, 4. Okay. Let's just take 5, 6, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. We can stop there. And here, maybe 1, 2, 3, 4, 5. Maybe I say this is 10. 1, 2, 3, 4, 5. This is 20. 1, 2, 4, 5. This is 30. Mapita kwinako. So that's 0. So when it's 2, 1, 2, it's 90. Okay. And it's 90. When it's 4, D is 45. When it's 6 here, D is 30. Okay. When it's 8, 8 is here. D is 22. 22 is 22.5. Somewhere there. And when it's 10, it's 18. 18 is here. That's 20. 18 is here. When it's 12, oh no, this one is here. When it's 12, which is 10, 11, 12 here, and it's 15, so it's 10, which means 10, that's 20, okay, 1, 2, 4, which is here, that's 15. When it's 14, that's 14 is here. When it's 14, it means there's 13, which means that's 10, 12, 13, somewhere there. Okay. Oh, when 12 is what? 11, 12, 15, 10. 15 is here. Okay. And it's there. And when it's N is 14, 14 is 13, okay, 10 here, 12, 13 here. When It's 16, it's 11, which means 16 is here, and then somewhere there. Okay, the 16, 18 is here, it's 10 somewhere there, it's 10 there. So if we draw the curve, it's coming like a curve. If you see it, coming like a curve, if we follow it like that, okay, you can continue like that, it will go like that, it will never come to zero. So that's how the this side, okay, even if you say 20, it will be 9, and 20 it will be 9, it will be somewhere there. Okay, it will be 9, be 9, even if you say 20 there, 8, 9, okay, something like that. So you have a curve like that one. That curve will never meet, this line will never meet that line, and will never meet the 0. Remember, direct variation, the line was a straight line passing through the origin. That gave us direct variation. But for inverse variation, it's a variation that never meets this one, this axis, and that never meets the other axis. It just come in that form. I think Zambirizo will discuss as we move on, looking at other examples. I think for today we stop here. See you in the next video. Thank you.